Welcome to a product interoperability demonstration between SPCECLAIM and Rhinoceros. This interoperability solution allows Rhino files to be opened directly in SPCECLAIM for intuitive 3D modification and creation of precise solid geometry. SPCECLAIM's intuitive 3D and Rhino's freeform modeling are naturally compatible, thus improving collaboration between product stylists and product engineers, resulting in better product designs and faster time to market. This demonstration highlights how SPCECLAIM enables product stylists and industrial engineers to modify 3D geometry while working within SPCECLAIM. A product stylist can utilize SPCECLAIM to open a Rhino file directly into the SPCECLAIM work environment, as shown here. This is a handle created in Rhinoceros that needs to have engineering geometry added to it. The first thing I want to do is to split this part into two halves. I can do this by adding a plane in the center of the part and splitting the part with this plane. Notice in the structure tree I have two solids, and when I hover over the geometry in the graphics window, it highlights the geometry I can delete if I choose to, so I did here. By deleting this half, you can focus on localized changes to only one half of the original part if you desire. Now the inside face of the part can be removed, creating a shell of the part, whereas now the geometry has walls of constant thickness. SPCECLAIM doesn't have features or a feature tree. Instead, you interact directly with the model by selecting on the geometry you want to change. SPCECLAIM's flexible modeling environment allows you to change the thickness of a single wall, or you can select more than one wall using SPCECLAIM's power selection technology, which will find geometry with similar characteristics. Now I can change the thickness of all the walls I have selected at the same time. To sketch within SPCECLAIM, I can just easily select on a face I want to sketch on and select one of the sketch tools from the sketch palette and start sketching. Within the SPCECLAIM sketch environment, I can even set up a mirror line so that as I create sketches, such as these circles, or even modify the sketches, the result is reflected or mirrored on the other side of the mirror line. When I exit the sketch, it puts me into Pull, one of our smart tools, which allows me to pull directly on the surfaces to dynamically create a modified geometry, or use Up to Surface, which automatically infers that I want to create precise solid geometry between these two selected surfaces. Now I have two bosses, which can be used for mounting purposes in this handle design. I also want to create a rib to add support to the handle. So here I can quickly sketch the rib profile using existing geometry of the model and then enter back into the 3D work environment. And again, using Pull, I can create a rib of a specified thickness. Notice I just selected on the rib profile and pulled on it, creating the geometry which adapts to the curvature of the side walls. At any time in SPCECLAIM, I can modify existing geometry by also using our Move tool, which can move, copy, pattern, and even rotate geometry dynamically. You don't have to wait for regeneration. The model updates in real time. Here, I have set up a pattern association between the two ribs using Control Drag on the Move tool, so as I modify one rib, the other updates precisely at the same time. Notice here, as I change the angle, the other rib changed to that precise angle. I can also create a channel on the top face of the part that follows the outside profile of the handle. I can do this again using Pull, but I can change its operation by using our Pull tool guides to the right by setting it to sweep along the channel. Now I created the height of the rib to sit just slightly below the overall height of the handle, but I can quickly change this by selecting on the face and pulling it up to the surface I want it to be coplanar with. Or, while I'm in pull, I can also draft geometry of the part that I have selected, and after selecting a neutral draft plane, I can specify a precise draft angle. And if I want to create rounds or fillets, I just select on the edges while in pull, and the system knows you want to make rounds and automatically makes them for you to a specified radius just by pulling. Now that I have finished with one half of the design, I now need to create the other half, and I can do that by simply mirroring the geometry I selected about a specified face, surface, or plane. Notice in the structure tree, I now have two solids. After making placeholders for them in the structure tree, as I'm doing here, and I can rename these placeholders. I'll rename them to right and to left, just for clarity. I can drag and drop these solids into them, thus turning this single part into an assembly by using our top-down design modeling techniques. SPCECLAIM also gives the user the ability to create drawings, which can be used for communication, collaboration, and for the manufacturing purposes. SPCECLAIM's drawings automatically places 3 views on the drawings for the user, and then allows you to modify the orientation of the views, allows you to quickly add new views. Here you can see as I spin the drawing, the 2D views are just representations of the 3D model. I can also add dimensions to geometry by selecting on the geometry you want a dimension as seen here. Remembering that I had a rib of 4 millimeters, an inside diameter of 8 millimeters for this boss, and an outside diameter of 16 millimeters. To further demonstrate SPCECLAIM's interoperability with Rhinoceros, I can now save this new modified file back as a Rhino file, and then open this file in Rhinoceros to review the changes. Again, here in Rhinoceros, I can just go and find that file, and with File Open, in comes in the changed file that was created or modified in the SPCECLAIM work environment. So thank you for joining us today for the product interoperability demonstration between Rhinoceros and SPCECLAIM, which demonstrates how this new solution greatly improves collaboration between design disciplines, resulting in better product designs and faster time to market. I hope you enjoyed the demonstration.